section 6.2 is solving trigonometric equations. Some parts of it are squinting, where you have to say, where would tangent be square root of 3? You kind of have to squint and figure that out. And then some parts of this process are practically algebraic. We solve by factoring sometimes, just like we do polynomial equations, quadratic equations. We use the same thought processes as for solving other types of equations. We just have to squint when we get to that part, where is sine negative square root of 2 over 2. So what helps me is just to go ahead and draw my first quadrant of the unit circle. Not going to label the whole thing, but especially when I'm looking for tangent and cotangent, it helps me to have those ordered pairs in the first quadrant written down. We're going to try our best to get through 1 through 37 today, and then 39 to 55 tomorrow. So 1 through 37 will be the homework if we're able to get that far. Page 479. Let's just start off with an easy one. Now the reason we're going to try to get 1 through 37 today is after 37 the directions change. Make sure you're reading the directions carefully so you know exactly what we're looking for here. 1 through 37 say find all solutions of the equation. That doesn't just mean in one revolution of the unit circle. That means in infinitely many revolutions of the unit circle. You find the solution in one revolution of the unit circle, and then you figure out a way to write and all of its coterminal angles. All right, where on the unit circle, answer this question first. How many times on the unit circle is cosine negative 1? Just one. At how many radians? At pi radians. So t equals pi would be one solution to that equation in one revolution of the unit circle. But how can I get all of its coterminal angles? What would I have to add to pi to get all of its coterminal angles? Multiples of 2 pi. 2 pi times 1, 2 pi times 2, 2 pi times 3. That's all of its coterminal angles. So I'm going to use the letter n to stand for an integer. And if n is the number of revolutions we're making, then when n is 0, t is just pi radians. At pi radians, cosine is negative 1. Then if n is 1, we would have 3 pi radians. And cosine of 3 pi radians is negative 1. If n is 2, would be on the third revolution of the unit circle. So that really does capture all the coterminal angles. Pi plus all of its coterminal angles. N is just an integer. Actually, just a whole number. 0, 1, 2, 3, 4. That takes care of infinitely many revolutions around the unit circle. All right. Let me write this just on this problem, and I won't write it anymore. Where n equals 0, 1, 2, dot, dot, dot. That's what n is understood to mean. All right. Number 4. How many times in one revolution of the unit circle is cotangent going to be -1 over square root of 3? 2 times. In what 2 quadrants is that going to happen? 2 and 4, wherever you have a positive divided by a negative or a negative divided by a positive. So I'm making myself a mental note here. I'm looking for quadrant 2 and quadrant 4 solutions. Now I know that's going to happen. Forget the negative for a second. I just need to figure out whether cotangent alpha is 1 over square root of 3 at the pi over 6's or the pi over 3's. Cotangent is which coordinate divided by which? Well, the x and the y. The x divided by y. Tangent's y divided by x, cotangent's x divided by y. So which one of these, if I took the x and divided it by y, would give me 1 over square root of 3. That means you'd flip the y. X divided by y would be square root of 3 over 2 times 2 over 1. The 2's would cancel, but that would leave my square root of 3 in the numerator. So it must be these pi over 6's. If I said x divided by y and flip the y and cancel the 2's, that square root of 3 would be in the denominator. So my first quadrant solution, if this were positive, would be pi over 3. Now what's the corresponding point in the second quadrant? 1, 6, 2, 6, 3, 6, I'm sorry, yeah, 1, 6, what just happened? 1, 6, 2, oh, I shouldn't be counting my 45. Okay, let's play like that didn't happen on film. That just wasn't working for a second. 1, 6, 2, 6, 3, 6, 4, 6 would have the same x and y coordinates. So 4, 6 or 2/3 pi, alpha equals 2/3 pi, and then how could I write all of its coterminal angles? You know what might help me? This is the mental picture I have. You can't see it. The fourth quadrant angle that would have the same ordered pair would be here. Could I get that just by adding 180 degrees or pi radians? Yeah. The period of tangent and cotangent is pi. So I don't have to add 2 pi n's. I can just add multiples of pi n. Now, when you're checking your answer, just let n be 0, n be 1, n be 2, and see if you're catching all the solutions. When n is 0, then you just have 2/3 pi. And at cotangent of 2/3 pi is -1 over square root of 3. When n is 1, we would be at 5/3 pi. Is that right here? Yep. And when n is 2, that would be 2/3 and 4/3, 7/3 pi. We're back right here. So that does seem to be capturing all the solutions. That's how you can check your answer. All right, number 6. Cosecant gamma is the square root of 2. Whenever I see square root of 2, I think, hey, that's going to happen at what fraction of pi? That's got to be your 45-degree angles or your pi over 4's. So, how many times in the unit circle is cosecant gamma going to be positive square root of 2? Twice. In what quadrants is cosecant going to be positive? Cosecant's your y, y's are positive in 1 and 2. Y's are positive, not x's are positive. So I'm looking for a quadrant 1 and a quadrant 2 angle. And it helps me to say if cosecant gamma is square root of 2, then sine gamma is 1 over square root of 2. What is that when you rationalize it? Yeah, square root of 2 over 2. So what would be the first quadrant angle where sine is square root of 2 over 2? Gamma equals pi over 4. That's, here's my mental image right here. Now, can I just add, since I'm looking for this second quadrant angle, could I just add 90 degrees? Keep adding just multiples of 90 degrees? If I keep adding multiples of 90 degrees, I'm going to pick up these third and fourth quadrant angles as well. And I can't do that. So I have to say pi over 4 and all of its coterminal angles. How do I say all of its coterminal angles? Plus 2 pi n. Or the second quadrant angle would be what? 1/4, 2/4, 3/4 pi, and all of its coterminal angles. You can't just say pi over 4 plus multiples of 90 degrees, or you would pick up the two third and fourth quadrant angles where sine is negative. Now, Miss Sarah, we didn't get as far as I thought, and we have it on video. Going to have it on video by sometime this afternoon, and I'll save you these notes. Okay. Okay, let's do one more. Number 8, I'm glad you stayed for this one. Number 8, cosine x equals negative pi over 3. Now, I could find the cosine of negative pi over 3, but is that what we're doing? No, we don't have x equals cosine of negative pi over 3, or I would just take the x coordinate of that angle and that would be my answer. I'm looking for the angle whose cosine is negative pi over 3. How do I find an angle whose cosine is something? I can use inverse cosine, so I could pick up my calculator right now and say x is inverse cosine of negative pi over 3. Actually, why don't you go ahead and do that? I want you to see something. Inverse cosine of negative pi over 3. So, okay, had a rough morning. Error? What has happened? Our batteries died all at the same time? Domain? Oh, you got a 1. Hold on, Terry. You said x equals inverse cosine of negative pi over 3 and got 1? No, it's not 1 over cosine, it's inverse cosine. You just found secant of negative pi over 3. All right, we're all getting errors. Why? It's not the negative that's causing a problem. I can find an angle whose cosine is negative. So what's the problem? Radian. Punch negative pi divided by 3 on your calculator. What is that? Negative pi divided by 3. Negative 1 point. All right, about negative 1.05. The angle whose cosine is negative 1.05. What's wrong with that? No, an angle can be negative. An x value can be negative. What is the range of sine and cosine? How low does it go to how high does it go? Not the period, the y values. From negative 1 to 1. When you graph that function, it goes from negative 1 to 1, never higher than 1, never lower than negative 1, unless there are vertical shifts or amplitude or something like that going on. So to say find an angle whose cosine is less than negative 1, there's no such guy. There's no such critter. There's no solution. Because negative pi over 3 is less than negative 1. You can't find an angle whose sine or cosine is greater than 1 or less than negative 1, because the range of sine and cosine is just negative 1 to 1. Because there are problems that don't have solutions. This is one of them. We've had that happen before. We've solved equations and written no solution before. Terry, it's saying domain error because negative pi over 3 is outside the domain of inverse cosine. You can't take inverse cosine of a number that's bigger than 1 or less than negative 1, because no such angle exists. Yeah, let me write you a note right here. So, best way to write it. Because I was looking for the angle whose cosine was this. Because you take cosine of angles. If I say cosine x, x is an angle. It's some angle on the unit circle. And so I'm looking for the angle whose cosine is that. Just like in number 2, I was looking for the angle whose cosine was negative 1, we found that angle to be pi radians. And in number 4, I was looking for the angle whose cotangent was this, and we found it to be 2/3 pi radians. See you, Miss Sarah. That's what we're looking for on all of these problems, the angle whose cosecant is square root of 2. The only reason that I didn't have to use inverse cosecant here is because I could squint hard enough to figure out the angle whose cosecant was that. The point I was trying to make here is you can't squint hard enough to find the angle whose cosine is negative 1.05, because there is no angle whose cosine is negative 1.05. All right. Any other questions on that one? Watch out, it happens on one of your odd problems. All right, number 10. Cosecant theta times sine theta equals 1. How many times on the unit circle is cosecant times sine going to be 1? What, Misty? Once? I'm gonna break into Lionel Richie if somebody says 3 times. Pretty much every time, because cosecant's the reciprocal of sine. Pretty much all the time, and I'm glad you qualified that with pretty much, because there is an exception. 99 times out of 100, cosecant times sine is 1. But when is it not? When you can't find cosecant. So whenever sine is 0, cosecant's undefined. Where is sine 0? At all the whole pi's. So, cosecant theta times sine theta equals 1 anywhere cosecant theta is defined. So theta is any angle except multiples of pi. Now when you look in the back, they're going to have that written in big fancy set notation. I don't care about the big fancy set notation, I just want to show you what it looks like. The set of all thetas such that theta is not equal to pi n. All the angles such that theta isn't a whole pi. Everywhere else on the unit circle, and infinitely many revolutions of the unit circle, that would be true. Good job. Yes, ma'am. Oh, I left out my prefix there. Would that help you? No, that's not right. Cosecant times sine is 1 anywhere cosecant is defined. Right. And it's defined everywhere except for the whole pi's. It's not defined at the whole pi's. For example, at 0 pi. What are we talking about? Sine? Sine would be 0. Cosecant would be 1 over 0. 1 over 0 is undefined.
Okay, so if we did, okay, we were looking at the pi over 6, the
Yes, and 1/2 times 2 does give you 1. So it's true everywhere except for the whole pi's, because at the whole pi's, cosecant's undefined.
I just think it an example.
Yeah, that's a perfect thing to do. Pick an example and see that it's true. All right, number 12. Seem to take a leap in level of difficulty. I can't squint hard enough to tell you an angle that if I tripled it and took the sine and then doubled that, and then added the square root of 2, I'd get 0. I can't do that in my head. But if we just call this ugly, I know how to solve 2 ugly plus square root of 2 equals 0. How would I get the ugly by itself? Subtract square root of 2 and divide by 2. Then we would just have sine 3 theta equals negative square root of 2 over 2. Now, how many times on the unit circle is an angle going to have as its sine negative square root of 2 over 2? It's going to happen at the quarter pies in quadrant 3 and quadrant 4. Now, when I find those 2 quarter pi angles in quadrant 3 and quadrant 4, that's not going to tell me what theta is, that's going to tell me what 3 theta is. So I'm going to set 3 theta equals, what's that third quadrant quarter pi? 1/4, 2/4, 3/4, 4/4, 5/4, and then 6/4, 7/4. Am I going to be able to just use 5/4 and multiples of 90 degrees? Nope, I'd pick up my first and second quadrant angles, so I'm going to have to write these two answers separately. I'm going to say 3 theta is 5/4 pi, and how do I say all of its coterminal angles, plus 2 pi n, or 3 theta equals 7/4 pi, and all of its coterminal angles. And then one last step, how do I solve each of those equations for theta? Divide by 3. And make sure you divide every term by 3. 5/4 pi plus 2/3 pi n, or theta equals 7, that's 7/12, or 5/12, plus 2/3 pi n, or 7/12 pi plus 2/3 pi n. Now you could try some n equals 0, n equals 1, n equals 2, just to make sure you're catching the right angles. If I graphed y equals sine 3 theta, what would the period of that function be? Y equals sine 3 theta. What's the period? The normal period for sine is 2 pi, and I'd have to divide it by the coefficient of x, so the period of this function is 2/3 pi. That's why we're adding multiples of 2/3 pi, because the period of this function changed. All right, I don't see us getting to 37. 14's pretty much exactly the same thing. Let's do 18, and then I'll tell you where to stop in the homework. How many times in one revolution of the unit circle is cosine positive square root of 2 over 2? Twice. In what 2 quadrants? We're talking about cosine, not sine. 1 and 4. So when I find that first quadrant angle and that fourth quadrant angle, that won't be what x is. That'll be what the argument is. What's the first quadrant angle where cosine is square root of 2 over 2? Pi over 4. That means 4 times x, not 4 divided by x. 4x minus pi over 4 equals pi over 4. And all of its coterminal angles. Or 4x minus pi over 4 equals, what is the fourth quadrant quarter pi angle? Yeah, I'll have to go 4 fourths, 5 fourths, 6 fourths, 7 fourths. 7 fourths pi and all of its coterminal angles. And just solve both of those equations for x. First equation, when I add 4 pi to both sides, I have 1/4 pi plus 1/4 pi is pi over 2 and all of its coterminal angles. Let me show you one thing with my not red ink pen. I got a blue. Yeah. When you add pi over 4 to both sides, on the right-hand side, you're just combining like terms. When you add, you can only combine like terms. That's why I'm not adding pi over 4 to 2 pi n. When I divide by 4, I have to divide all three terms by 4, just like I do in algebra. And the other equation, when I add pi over 4 to both sides, I'll have 8/4 pi, which is just 2 pi plus 2 pi n. There's a simpler way to write that. This is okay, but if I'm going to be adding multiples of 2 pi to 2 pi, that's just multiples of 2 pi. If n is 0, then 4x would be 2 pi. If n is 1, then 4x would be 4 pi. That's just multiples of 2 pi. Isn't 2 pi equivalent to 0? Think about it that way. 2 pi is equivalent to, it's coterminal with a 0 radian angle. If you started at 0 and just added multiples of 2 pi, you'd have multiples of 2 pi. And then divide both sides by 4, and you would just have multiples of your half pi's. Is 2 pi coterminal with 0 radians? Yeah, that's the same as 0 radians. What's 0 plus 2 pi n? It's just a shorter way of writing the same thing. If you had written, if you left as your answer, totally skip that step and divide both sides by 4. If you wrote pi over 2 plus pi over 2n, I'd count that right. It's just not the simplest way you can write it, because 2 pi is coterminal with 0, and 0 plus 2 pi n is just 2 pi n.
Is 2 pi n multiplication like n is any ratio?
Yes.
So 2 pi is 0, 0 times n is 0.
And that's one of the solutions. If you let n be 0, then x would be 0, and check 0 in this solution right here. 4 times 0 is 0. 0 minus negative pi over 4 is negative pi over 4. Oh, don't tell me. Cosine of negative pi over 4. Crap. Why am I getting a positive there? I was thinking y's instead of x's. That does work. Cosine of negative pi over 4 is positive square root over 2. Square root of 2 over 2. I was thinking in the fourth quadrant, it's negative, but that's sine, not cosine. Good job, Corey. All right. This squinting is not easy. In my opinion, this is the hardest section on this test. Y'all have gotten pretty good at proofs. Everything we do after this section is just using formulas, and I'm going to give you most of the formulas on the test. They're formulas you don't need to just memorize and walk around with. So those are pretty easy. This is the hardest thing. So tonight, try number 20 is the same. I believe you could do it. 22 is the same. 24 is the same. 26. Yeah, you could handle that. 28. Let's make it 1 through 29 odd. Do the best you can. Don't lose any sleep over it. We'll do some more tomorrow.